Experior's electrical master or contractor practice exam is generally considered more difficult than Mike Holt's online practice exam. The Experior's exam firstly covers a wider range of topics, secondly includes more specialized and challenging questions, thirdly requires a deeper understanding of the National Electrical Code and electrical theory, and fourthly is designed to simulate the actual exam experience, including time limits. Mike Holt's exam firstly focuses on the most common areas tested in the actual exam, secondly provides clear explanations and step-by-step solutions, thirdly is a more user-friendly experience with an intuitive interface, and fourthly is less comprehensive and challenging than Experior's exam. Both practice exams are valuable tools for preparing for the exam. Experior's exam will provide a more realistic and challenging test of your knowledge and comprehension. It is important to understand the National Electrical Code, or NEC, which is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years. The NEC contains requirements for various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. Understanding the NEC is crucial for electrical contractors and master electricians to ensure safe and compliant installations. Overcurrent protection is a critical aspect of electrical safety. Overcurrent devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating, fires, and equipment damage. Circuit breakers are resettable devices that trip and interrupt the circuit when an overcurrent condition is detected. Fuses are one-time devices that melt and break the circuit when an overcurrent condition occurs. The selection and coordination of overcurrent devices are essential to ensure that the circuit is properly protected and that the overcurrent device trips before damage occurs. Grounding is another important aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to quickly trip the overcurrent device and clear the fault. Grounding also helps to reduce the risk of electric shock by providing a common reference point for the electrical system. There are several types of grounding systems, including equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment to ground. System grounding connects the neutral point of the electrical system to ground. Wiring methods refer to the types of conductors and raceways used to install electrical wiring. Conductors are the wires that carry electrical current. Raceways are enclosures that protect and support the conductors. There are several types of wiring methods, including rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheath cable. The selection of the appropriate wiring method depends on the application and the environment. Equipment installation involves the proper installation of electrical equipment, such as panel boards, transformers, motors, and lighting fixtures. Equipment must be installed in accordance with the NEC and the manufacturer's instructions. Proper installation ensures that the equipment operates safely and reliably. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include local building codes, state electrical codes, and industry standards. It is important to be familiar with all applicable codes and standards to ensure that electrical installations are safe and compliant. Electrical theory is the foundation of electrical engineering and provides the basis for understanding how electrical circuits and systems work. It encompasses fundamental concepts such as voltage, current, resistance, power, and energy. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. It represents the force that drives electric charge through the circuit. Current, measured in amps, is the rate of flow of electric charge through a circuit. It is the amount of charge that passes a given point in the circuit per unit of time. Resistance, measured in ohms, is the opposition to the flow of current in a circuit. It is the property of a material that impedes the flow of electric charge. Power, measured in watts, is the rate at which energy is transferred or consumed in a circuit. It is the product of voltage and current. Energy, measured in joules, is the capacity to do work. It is the product of power and time. Ohm's law is a fundamental law of electrical theory that relates voltage, current, and resistance. It states that the voltage across a resistor is equal to the product of the current through the resistor and the resistance of the resistor. Mathematically, Ohm's law is expressed as volts equals amps times ohms. Kirchhoff's laws are a set of two laws that describe the behavior of current and voltage in electrical circuits. Kirchhoff's current law, or KCL, states that the sum of the currents entering a node, or junction, in a circuit is equal to the sum of the currents leaving the node. Kirchhoff's voltage law, or KVL, states that the sum of the voltages around any closed loop in a circuit is equal to zero. Series circuits are circuits in which components are connected in a single path, so that the same current flows through each component. In a series circuit, the total resistance is equal to the sum of the individual resistances. The voltage drops across each component add up to the total voltage of the circuit. Parallel circuits are circuits in which components are connected in multiple paths so that the current divides among the paths. In a parallel circuit, the reciprocal of the total resistance is equal to the sum of the reciprocals of the individual resistances. The voltage across each component is the same and is equal to the total voltage of the circuit. Alternating current, or AC, is a type of electrical current that periodically reverses direction. It is the type of current that is used in most electrical power systems. Direct current, or DC, is a type of electrical current that flows in one direction only. It is the type of current that is produced by batteries and solar cells. Transformers are devices that are used to transfer electrical energy from one circuit to another through electromagnetic induction. They are used to step up or step down the voltage of an AC circuit. Motors are devices that convert electrical energy into mechanical energy. They are used to power a wide variety of equipment, such as pumps, fans, and compressors. Generators are devices that convert mechanical energy into electrical energy. They are used to produce electrical power in power plants and other applications. Capacitors are devices that store electrical energy in an electric field. They are used in a variety of applications such as filtering, energy storage, and timing circuits. Inductors are devices that store electrical energy in a magnetic field. They are used in a variety of applications such as filtering, energy storage, and resonance circuits. Diodes are semiconductor devices that allow current to flow in one direction only. They are used in a variety of applications such as rectifiers, switches, and voltage regulators. Transistors are semiconductor devices that can be used to amplify or switch electronic signals. They are used in a wide variety of applications such as amplifiers, oscillators, and digital circuits. Integrated circuits, or ICs, are electronic circuits that are fabricated on a single semiconductor chip. They are used in a wide variety of applications such as computers, cell phones, and consumer electronics. Digital circuits are circuits that operate on digital signals, which are signals that have only two possible values, typically represented as 0 and 1. They are used in a wide variety of applications, such as computers, digital signal processing, and control systems. Analog circuits are circuits that operate on analog signals, which are signals that can have any value within a continuous range. They are used in a wide variety of applications such as amplifiers, filters, and sensors. Thevenin's theorem is a theorem that states that any linear circuit can be replaced by an equivalent circuit consisting of a voltage source in series with a resistor. Norton's theorem is a theorem that states that any linear circuit can be replaced by an equivalent circuit consisting of a current source in parallel with a resistor. Superposition theorem is a theorem that states that the response of a linear circuit to multiple sources is equal to the sum of the responses to each source acting alone. Maximum power transfer theorem is a theorem that states that the maximum power is transferred from a source to a load when the load resistance is equal to the source resistance. Power factor is a measure of how effectively electrical power is being used in an AC circuit. It is the ratio of real power to apparent power. A power factor of 1 indicates that all of the power being supplied to the circuit is being used to do work. A power factor of less than 1 indicates that some of the power is being wasted. Harmonics are sinusoidal voltages or currents that have frequencies that are integer multiples of the fundamental frequency. They can cause problems in electrical systems, such as overheating of equipment and interference with other electronic devices. Transient voltages are short-duration, high-voltage spikes that can occur in electrical systems. They can be caused by lightning, switching operations, or other disturbances. Transient voltages can damage electrical equipment and cause disruptions in service. Electrical safety is a critical aspect of electrical work. It is important to follow safe work practices and to use appropriate personal protective equipment, or PPE, to prevent electrical shock and other injuries. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Ground fault circuit interrupters, or GFCIs, are used to protect people from electrical shock by interrupting the circuit when a ground fault is detected. Arc flash is a dangerous electrical phenomenon that can occur when a high-voltage arc forms between two conductors. Arc flash can cause severe burns, blindness, and even death. Electrical codes and standards provide guidance on safe electrical practices and equipment installation. The NEC is the most widely adopted electrical code in the United States. Other codes and standards may also apply, depending on the location and the type of electrical installation. In Florida, electrical contractors and master electricians must be licensed by the Florida Department of Business and Professional Regulation, or DBPR. To obtain a license, applicants must pass an examination and meet certain experience requirements. Continuing education is required to maintain an electrical license in Florida. Electrical contractors and master electricians must complete a certain number of continuing education hours each year to stay up to date on the latest codes and standards. The electrical exam covers a wide range of topics, including the NEC, electrical theory, wiring methods, overcurrent protection, grounding, and equipment installation. It is important to study all of these topics thoroughly to prepare for the exam. There are many resources available to help you prepare for the electrical exam, including textbooks, study guides, and practice exams. It is also helpful to attend a review course or workshop. It is important to manage your time effectively during the exam. Read each question carefully and answer the questions that you know first. Then go back and answer the more difficult questions. If you are unsure of the answer to a question, eliminate the answers that you know are wrong and then make an educated guess. Staying calm and focused during the exam is important.